For the last section of Chapter 3, we are going to be exploring exponential models. The general equation for an exponential model is y equals a times e raised to the power of bx. So for the first example, it says find the exponential model that fits the points 0, 5, and 3, 14. So if I were to graph it, it would actually pass right through those 2 points. The first thing I read in the problem is that it does say find the exponential model. Because it says that, I know I'm using this general equation. They give me 2 ordered pairs, 0, 5, and they also give me 3, 14. I'm going to use those ordered pairs to solve for the constants. The constants are a and b. If one of the ordered pairs has a 0, I'm going to plug that one in first. I'll show you why in a second, but it will help you solve the problem faster. Okay, so I'm going to plug 0, 5 in first. So it's y equals a e to the bx. So y is 5 a e to the b times x. What's x? X is 0. Okay, b times 0 is just 0. Okay, e to the 0 is just 1. So 1a equals 5, which means a equals 5. So that helped me find my first constant right away. So now I know that my equation is going to be 5e to the bx, and I still need to solve for b so I can find the last value in my equation. So I'm going to use the point 3, 14 to solve for b. So let's see, y is 14. 5e to the b times 3, I'm going to say 3b. Okay, now I'm going to solve for b. I'm going to divide the 5 to the other side. And because the base is e, I'm going to use natural log to solve this. Okay, the natural log of e to the 3b is just 3b. Okay, now I need to divide by 3 on both sides or multiply by 1/3. Both ways are equally correct. Okay, so this is my value for b. Because I'm not using a calculator, this is an exact value. If I was using a calculator, I would just put this in the calculator and get a decimal approximation. Okay, so now that I have b, I'm going to plug it back in the equation I had. And it's going to be a little ugly for now. 1/3 ln of 14 over 5 times x. Okay, I need to simplify this. I can't leave it like this. Okay, I'm just going to rearrange my exponent a little bit. When you get more comfortable with these, you probably will not need to do that. Okay, I'm going to put the ln of 14 over 5 first. And then what's left? The 1/3 x. Okay, all I did was rearrange the order of the exponent. I didn't change the value of the exponent. Okay, the reason I do this though is because if I have e to the ln of 4/5, I can simplify that. Okay, e to the ln of 4/5, the e and the ln kind of cancel out, but the 14 over 5 comes down. Okay, and then I have the 1/3 x in the exponent spot left there. I'm just going to rewrite it as x over 3 so it looks a little nicer. And this is going to be my general equation, or my equation for this, my specific particular equation for this scenario. Okay, now I'm going to use this equation to evaluate different points along this function. Okay, so the first one says, for b, it says find the value of y when x is 6. So I'm just going to plug x equals 6 into that equation that I already found. Okay, and the bigger challenge really is just the fact that we do not have a calculator. X is 6. 6 divided by 3 is just squared. Let me think. I can multiply that. That's not bad. 196 over 25. It's up to you how you want to simplify it. I think I'm going to cross cancel because I can cancel a 5 out, and I'll be left with a 5 at the bottom. Okay, so y equals 196 over 5 is a good answer. If I was doing this with a calculator, it's not an approximate, it's actually an exact. It equals to 39.2, but you won't have a calculator, so you might as well practice without a calculator. Okay, so for part C, you're going to solve for x when you are given a y value. So it tells me, what is it? Y is 100. So I'm going to have 100 is equal to 5 times 14 over 5 to the x over 3. Okay, I'm going to divide the 5 over first. You definitely cannot distribute that because the 14 over 5 has an exponent being applied to it, an exponent with a variable. So you have not even any kind of clue what that's going to equal to. Okay, now again, how you solve this is up to you. You could do log base 14 over 5. You could do natural log. You could use common log. I'm going to use ln, but I will tell you the answer if you do it a different way so you can check. Okay, what am I going to do? I think I'm actually going to times this 3 over so I could kind of, so I just have less fraction. Okay, then I can divide by the natural log of 14 over 5. Okay, this is a reasonable answer. It's fair. It's simplified the best I can. I could expand a log on the bottom, but I don't know that it makes it any simpler. If you chose to do log base 14 over 5, then you would probably have 3 times the log base 14 over 5 of 20, and that's equally correct. Okay, the next example is a word problem, but it's going to be using the same general equation and the same kind of process, but it's a little trickier. Okay, it says in a research experiment, the fruit fly population increases according to an exponential model. Okay, once I see exponential model, that automatically tells me I'm using that equation that we defined on the previous example. Okay, after 2 days, there are 100 fruit flies. Okay, I see an ordered pair. I'm going to pull it out because once I have my ordered pair, I'm pretty much over the word problem. Okay, after 4 days, there are 700 fruit flies. Create a function to model the population of the fruit flies, then use the model to predict the fruit fly population after 3 days. Okay, so I first need to create my model. So I'm going to use the general equation to create my model. Okay, now I don't have a 0, which means this might be a little bit more work. Okay, so I'm going to go ahead and plug 2, 100 into equation. So y is 100 equals a times e to the x is 2, so 2b. Did that help me? Not really. Okay, I can't really solve it, so I'm going to go ahead and write the second equation and then see what happens. Okay, for 4, 700, I get 700 equals a times e to the b times x, 4b. Okay, well, I have 2 equations, 2 unknowns, so I'm going to solve a system of equations. There is more than one way to do it, so you may find a different way is better for you. I'm going to use the substitution method because it looks like it can solve for e fairly easily. So on the first equation, if I divide by e to the 2b, I get a. On the second equation, if I divide by e to the 4b, this is also equal to a. Since they both equal to a, I can use substitution method and set them equal to each other. Okay, and then hopefully I will be able to solve for b because that's what's in my equation. Okay, now depending on your algebra, you could do this differently. Okay, I found that some people like to do cross multiplication here, and then they solve it later. Okay, if I do cross multiplication like that, I get 100 e to the 4b equals 700 e to the 2b. Okay, and this is not necessarily the most efficient. So if you look at it later and realize there's a faster way, do it the faster way. Okay, I want to get the b's on one side. So let me think. Okay, since e to the 4b is bigger, I'm going to cancel the e to the 2b. Okay, I'm going to show extra steps. 100 e to the 4b minus 2b is 2b equals 700, and then I'm going to divide the 100 over to the other side. So e to the 2b equals 7. And yes, you could have done that in less steps. Okay, I'm going to do natural log to solve for b. Okay, so after all that, I got b equals 1/2 ln 7, or ln 7, the whole entire thing over 2. Either way is fine. Okay, I still need to find a, so I'm going to go ahead and plug it into, I could plug it in here, or really any other equation that has a and b in it. I'm going to plug it into this equation just because the numbers were smaller than the other one. But I would get the same answer both ways. Okay, so if I plug it in, I get a equals 100 over e to the 2 times b, and b is 1/2 ln 7. Okay, let's look at this. It looks bad, but it looks like stuff's going to cancel. Okay, the 2 and the 1/2 cancel, so then I'm just left with e to the ln 7. These twos, they're gone. E to the ln 7, that simplifies down to 7. So my a is actually just 100 over 7. Okay, I have both constants. Now I shall plug them back into my general equation. Okay, y equals a times e to the b times x. So 1/2 ln 7 times x. Okay, I'm going to simplify this. I don't want to leave it base e when I can make it a better base. Okay, I'm going to rearrange the exponent. You don't have to rearrange it. If in your head you can imagine what kind of good things you want to leave in your exponent. I'm going to keep the ln 7 in the front. Then I'm still left with 1/2 of x, which is really x over 2. Okay, if I do e to the ln 7, that simplifies down to 7. And I keep the x over 2 out there. Okay, this is a good answer like this. There's often an equivalent answer that's just as good, and as long as you show your work, I'm fine with whichever way you do it. Okay, all that work was to get the equation, but let me go back to the question. Okay, create a function to model the population of fruit flies. Okay, I did that. Then use the model to predict the fruit fly population after 3 days. Okay, now let me see, are the days the x or the y? 2 days, 100 fruit flies. So the days are the x. Okay, so I'm going to plug in 3 days for x. Okay, it will not be bad, except for the fact that I don't have a calculator. 3 over 2. Okay, let's see. Now, how you simplify this is up to you, but you do need to simplify this. What is this? This is really saying the square root of 7 to the 3rd. I'm going to keep going. 100 over 7. What is the square root of 7 to the 3rd? 7 to the 3rd is 7 squared times 7. So actually, this turns into 7 square root 7, which means that this 7 will cancel out. So I get y equals 100 square root 7 fruit flies. And because I don't have a calculator and because I like exact answers, I can leave it like that. If I wanted to put it in a calculator, I could put it in the calculator. I think you get something like 264 fruit flies.